Hello, my name is Anthony DeMarzo, and I'm an IT student at Major College. Today I'm going to talk to you about IP subnetting and VLSM. So what is subnetting, you might be asking yourself? Well, subnetting, simply put, is taking a larger network and making it into smaller ones. I'm going to explain to you how you go about doing this. Creating subnetworks is the act of taking bits from the host portion of the address and reserving them to define the subnet address instead. This will result in fewer bits being available for defining your host. There are 3 steps that go about creating a subnet. The first step is you create the number of required IDs, one for each LAN subnet and one for each wide area connection. Then you determine the number of required host IDs per subnet, one for each TCP/IP host and one for each router interface. And last, based on the previous requirements, you create the following: a unique subnet mask for your entire network, a unique subnet ID for each physical segment, and a range of host IDs for each subnet. For the subnet scheme to work, every computer in the network must know which part of the host will be used as a subnet address. The condition is met by giving a subnet mask to each machine. A subnet mask will name a 32-bit value that allows the device, after receiving the IP packets, to distinguish the network ID of the port of the IP address. The 32-bit subnet mask is made up of ones and zeros, where the ones represent the position that refers to the network subnet address. There are 3 classes for subnet masks. Class A, which is network, node, and node, or 255.0.0.0, or Class B, which is network, node, which is also 255.255.0.0, and then there's Class C, which is network, and node, which would be 255.255.255.0. You should also understand how the powers of 2 work for subnet in order to understand subnetting. So the powers of 2 would be like 2 to the first power, which equals 2, 2 to the second power equals 4, 2 to the third is 8, and 2 to the fourth is 16, and so forth. It's pretty simple. Now you should also understand what a CIDR is. While subnetting, you'll see something called classes interdomain routing, which is also named CIDR. This is the method the internet service provider uses to allocate a number of addresses to accompany your home. They provide the address and block size. For example, 192.168.10.32/28. This tells me what the subnet mask is. The slash notation tells you how many bits are turned on, and the maximum on bits is only 32 bits, of course. A bit is 8 bits, and there are 4 bytes in the IP address. I'm going to walk you through the subnetting Class C example. There are several ways to subnet, and the best way is what works best for you. In order to make this simple, and believe me, it's a lot easier than what it sounds, all you have to do is answer these questions. How many subnets does the mask produce? How many hosts per subnet are available? What are the valid subnets? And what is the valid broadcast of each subnet? What are valid hosts in each subnet? And for our demonstration, we're going to use the following IP address and subnet mask. For the address, we're using 192.168.10.0, and for the mask, we're using 255.255.255.128. Now follow along with me as I break this down. So you figure out how many subnets first. Since 128 is 1 bit, the answer is going to be 2 to the first power equals 2. Easy so far, correct? And then how many hosts do we have in our subnet? Well, we have 7 bits off, so the equation would be 2 to the 7th power minus 2, which would be 126 hosts. Once we've figured out the block sizes of the mask, the number of hosts is always the block size minus 2. The valid subnets are figured out by subtracting 256 minus 128, which equals 128. You start at 0 and count the block size. Your subnets would be 0, 128. Just by counting your subnets when counting your block size, you really don't need to do steps 1 and 2, quite honestly. The broadcast address is always a number right before the next subnet. The number right before the value of this next subnet is all host bits